Hello. Like I said, my name is Paul Davis. I'm a software engineer, senior software engineer at Cloudant, which actually is now IBM. And today we're going to be talking about hot code loading, releases, upgrades, the production side of running an Erlang system, and specifically about a tool I've been working on to try and make the upgrade side of this a lot more easy. So the first side, hot code loading. Most Erlangers have actually used this, even if they don't know that they have. When you do C module name in a shell, you're actually hot loading code into a running Erlang VM. And most of the time when we're just, editing code and compiling it and running it, it's not a big deal. But hopefully it'll show that it's quite powerful to use. The biggest constraints here is you're actually limited to 2 versions of code in the VM for a given module. The interesting thing is that processes running old code are killed as soon as the 3rd version is loaded. And the way that you upgrade a process running code is to call into the exports table of any module. So a quick example. This is just a small thing that prints the version of the module and then loops. The thing to notice there is the qualified module : function name. So when we upgrade the code, that will actually load new code. So this is just a simple shell session. This starts the process. The thing to note that we're actually upgrading code is I just added a prefix on the lines there that are being printed. And it just shows you that each time I recompile the module, it's changed the actual code that it's running. A very simple change is that if you just take out that module : it's no longer qualified, so it's no longer upgrading the code as the module changes. So a little bit harder to read, but on the 4th entry in the shell session there, I just monitor the process to show when I compile and install the new version that it ends up being killed. This is very useful in production. For instance, Saturday morning when things are burning down and you want that log message to see, what air is being swallowed. It's, just a handful of steps to actually change production machines to actually show you what you should have been logging a long time ago. There are a number of ways that this can make your life more difficult. There's an L and NL for load and network load. And one of them will load it into local VM, and one will load it into every VM that's connected. The interesting thing about network load is if one of the machines reboots, it'll lose that. And so if you've patched something Saturday morning and a node reboots and it comes back, you'll be woken up an hour later. Another interesting thing, if you run an upgrade on a node that's been patched, it'll lose it. So that will, be another wake up in a couple days. There's also the question of, what code has been patched by some other operator that was, woken up on the last shift. And then the other thing is code changes for behaviors, gen server, gen event, all those things. They don't actually have their code change run when you're doing hot code loading at this kind of a low level. Another useful thing for doing this when you're in operations is figuring out which processes might die. And there are a couple BIFs that you can use to check for which processes are running old code, which modules have old code still in the VM. And that's useful during upgrades and when you're hot patching code, just so you kind of have an idea of where your system is at, and then you can investigate why certain processes haven't been upgraded. And that just kind of is, an example of the basic, primitives in the VM that we use. And for a little more background, when we talk about releases, I don't know who's familiar with actual kind of production deployments, but, an Erlang release is more or less a tarball that contains enough stuff to kind of run, your entire Erlang application, application with a capital A there. The interesting thing about this, there's a lot of documentation, there's a lot of man pages, and there's a lot of stuff in learnings from Erlang. They're very configurable, and so it kind of really depends on how your ops system is set up, whether or not you include an Erlang VM in the release, whether or not you include source code, all that different stuff in your actual releases. in general, it's basically just a set of compiled applications, and it's with extra metadata that kind of describes the release, and generally distributed as a single file. The outline of an unpacked release is, optionally the VM, the lib directory is where all of your compiled code goes with the app-version structure. And then the releases directory is the important thing for managing and upgrading releases. The rel version subdirectories contain all of the metadata specific to a specific, contain all of the data specific related to a specific version of your application. The releases, capital releases file, contains a textual Erlang term describing all of the releases that have ever been on that node or have ever been unpacked on that node. And then the start URL data tells the boot scripts what version of the Erlang VM to boot, and then the version of which release version to boot. And that is, for operations, that's a very useful file for shell scripts to know what's currently on your node so that you can connect to the right, using the right versions of all your applications when you connect. So most of that I've just covered. The one thing I skipped, the releases rel version, relname.rel, are very useful for describing exactly what a release contains. It gives you your entire list of applications and their specific versions. And then the other thing, relname.boot. There is a relname.script which you can actually look at, and then the relname.boot is basically just a load that term to binary and write that binary to disk. And that binary version is what the VM actually uses to boot your release. So, assuming that you're all familiar with actually developing Erlang, the ways that you can actually generate a release, Systil is just kind of a very low-level library interface that you have to spend a lot of time reading man pages to actually understand. RelTool was kind of, my understanding was kind of an effort to make it easier to use Systils and try to give a lot more support in configuring your releases. Then Rebar came along, and a guy named Joe Williams that used to work for us wrote the release interface to Rebar, and that's basically kind of trying to make it easier for people to generate these things. Relix is a semi-recent come up. It comes from the Erlware group, and that's newer. It kind of eschews rel tools and kind of does everything by hand. And it has more of a complex version constraint solver. So for those of you who know, like if you have an application with dependencies that say, between version X and Y, and you have a set of those, and it tries to find the set of things that the set of applications and their versions that satisfy all those constraints. And then Net, which I've been working on, I basically did for the release generation is just modeled after Rebars, but hopefully a little bit more user-friendly, in that it does a lot of things like expanding tarbles and generating tarbles, rather than requiring that you script it on the command line. So once we have releases, which is a necessary step for upgrades, we can start talking about actually doing production-style hot code loading. And an upgrade is generally a set of instructions that takes a VM running release A and turns it into release B. And that means you can upgrade, you can downgrade, and it doesn't have to be linear. So you can upgrade from version 1 to version 2, and then you could go ahead and downgrade to version 1.1 dot something if for some reason you had that issue. In practice, mostly you just want to do upgrades. If you upgrade and you have a bug, generally you'll just write up, you'll fix the bug and make another upgrade. The other thing is, if an upgrade fails to apply, the node will reboot. And when you reboot during that, you just fall back into the version you tried to upgrade from. Right? So most of the time, the actual situation where I've upgraded it and all of a sudden I want to downgrade it doesn't happen that often. If you've made it through the upgrade, generally speaking, you should be good to go long enough to write another upgrade if there's something broken. So contents of an upgrade are very similar to a release, but it elides like the VM and some of the other kind of support files. The releases is a similar setup. You've got the rel version, relname.boot, The start.boot is from systools, and then you basically just have to copy it so that it's consistent with the way that releases are made. The other inconsistency, the rel name rel version is actually out a directory level, which is confusing. But the important part is that rel up there, which is the actual file that describes how to actually affect that change from A to B. Oops. Yep. So what is rel up? And this is basically a script written in an Erlang term format. It's textual. It's not the binary version of the term to binary, so you can actually open it up and read it and inspect it. So if you generate an upgrade, you can unpack it and look at that and see exactly what's going to be happening. It's built by compiling app-ups, which we'll talk about. And then the other thing is it's only using low-level instructions, which we'll talk about. The format for this thing is the version that it will get you to. So if you've got version 2 there we go, and then it's a list of I can upgrade from versions or I can downgrade 2 versions using that rel up. So an app up, very similar. They're very close to the same thing, except for an app up is just limited to a single application, and it can contain these higher level upgrade instructions. Systools is there's a systools call that's pretty straightforward to invoke. To actually collect those and compile them down. It's not quite a direct expansion, but it's similar to kind of a macro language of sorts, which we'll talk about. And it's got exactly the same format as rel up. So digging deeper, the macro. One of the interesting things with upgrades is you have to worry about not only adding and reloading, but also removing code over time. There are a lot of other instructions, things like just allowing you to execute an arbitrary function during the middle of an upgrade in case you need to synchronize, or things like changing supervisors we'll talk about later on. Then there's also instructions in newer Erlang VMs to upgrade the VM itself, which gets confusing, but is possible. So an example high-level instruction is just a tuple. And there's about 6 versions of this that basically just remove some of the options here. But just going through this quickly, mod is obviously the module you're going to upgrade. The mod type, if you do, generally speaking, it's always going to be a dynamic. If it's static there, you basically don't get as much support when you upgrade it. There's no code change, and it just kind of forcefully loads the version of the module that needs to be in the VM. The change soft is basically just changing the module version. The advanced extra is how you get the code change function in your gen servers to run. The pre-purge and post-purge have to do with the hot code loading. When I was talking about, there's 2 versions. The upgrade system allows you to say forcefully kill everything before I start the upgrade, and optionally forcefully kill everything after I finish the upgrade, or don't, and just let them hit the VM constraint. And then the dep mods is a list of dependencies. So if you have a module that requires a separate module to be upgraded first, that's where you would specify that. Sorry. Yeah, so when I said earlier that it's not quite a direct macro expansion, the interesting thing here is the dep mods, when you get into the compilation of app-ups into rel-ups, the dependency modules is mostly what that is, and it generates the graph of all of your dependencies and moves things together. So if you have a module in application A and it depends on a module in application B, those upgrade instructions will be moved in the same section of the rel-up, right? Which can lead to confusing behaviors during your upgrade. Then the expansion of that is when you suspend all the processes running the module, in this particular example, any of your dependencies that might have been listed will be loaded. Then you load the module you're upgrading, invoke its code change, and then let the process start running again. This is all handled by the sys module, and the gen behaviors take care of all of this for you. Some of the other instructions to be aware of. Point of no return, if you're ever reading a rel-up script, there will be an instruction there that's point of no return. There are only a few things that you can actually run before that, and most of those are just loading code into the VM. After that, when I said if there's an error during your upgrade, after that point of no return is when the VM will reboot. Before that, it will abort the upgrade. But generally speaking, there's not much that goes on before that. Apply the MFA, allows you to run arbitrary code, is one of the few instructions that you can run before point of no return. This sync nodes, I haven't actually used it yet, but theoretically it should allow you to synchronize all of your nodes in the upgrade process. But I think the downside is that you have to synchronize all of your nodes in the upgrade process, if that makes sense. Then yeah, add, remove applications. Obviously, if you're adding an entire application, you can load it in one instruction, removing them. If you want to have a blunt hammer with your upgrade, you can just restart your application and let supervisors restart everything. You can also do that with the entire emulator. And then the restart new emulator, it gets complicated, but basically what it does is it loads the new standard lib kernel prim code, and then sets some temporary release stuff, reboots into the new Erlang VM version, picks it up, and then finishes the upgrade. I don't have much experience yet with myself, but it is there. So this is basically the hard part of upgrades, is how we generate these app ups, right? I mean, those instructions, you can write them by hand, but usually they're very tedious. Rebar has a very straightforward algorithm for kind of generating this. And it basically just compares the beam files on disk. You have to expand two balls until to generate the upgrade between the two, and it will just do a diff basically. And then if it's a supervisor, it gets a special upgrade instruction, and if it has a code change function exported, it becomes a code change upgrade. When you get into kind of more advanced things, for instance, one example off the top of my head is I had a Gen server that was running, and it had an LRU implementation that only it used. And if you update them in the wrong order, then it would crash. So one of the things that we did there was to take Rebar's app up and then go in and reorder instructions and then package everything back up, which gets to be a pain. If you're, most people have a build server running all of this, so you have to kind of manually intervene. And so what I've been working on is trying to affect these sorts of minor tweaks to the app ups based on module attributes. So right now, the kind of the set of attributes that we use are just a priority to kind of give you a rough way of saying which modules to upgrade first within the context of an application. The extra is if you need to pass anything to your code change function. The dependencies, timeout is not something I've ever run into, but it's basically when that instruction to suspend a process, that could time out. And so this lets you, if you, for some reason, have a slow-moving gen server. Then there's the pre and post strategies, which is that purge, whether or not you kill anything forcefully before you start and after you finish the upgrade. And then the ability to call a function at various points within the upgrade. And then that's just an example of what I mean by module attributes, if anyone's not familiar. Once you have all of your app ups, the next step is to create that relic file. Like I said, there is the sysdils maker up, but obviously, you'd want a tool to kind of invoke all of that. Rebar, relics, net, any of these could kind of equal, except for Rebar has a lot more manual script steps that you would have to add. So once we have our upgrade created, we have to figure out how to actually apply this thing. And so if you have an application running, you've expanded a release, you've started it, and it's running, the tarball for the upgrade actually goes in its releases directory. And then there's 3 release handler functions. So the first thing you'll do is you'll unpack it, then you'll install it and make permanent. The install release step, between the install and the make permanent step, it's important to note that if the node reboots anywhere in there, it goes back to the version where you started. So that's what I'm saying, like if you install the release and you think it's not working, you can just kill the node and it'll come back up in the old version, right? So unpacking the release doesn't do a whole lot. It's basically just kind of saying, okay, this is a valid release if it's. It's kind of interesting, by default releases, or upgrade targets will include all of the application code. So if you, like currently it has a copy of kernel and it has a copy of XML and whatever you've added. And it just expands it over top, but it does the keep old files thing from tar, so it only adds new code. And then it updates that releases that it's got that on disk and it's been unpacked. The install release is the one where you cross your fingers as an operator. But the basic idea is that it'll upgrade kind of the information about each application that it's going to upgrade to. It's going to apply that relup script, and then it's going to notify each application of the environment changes from the new appname.app files that you've loaded or the sys.config files. And it runs optionally if you're, I don't know how to describe this in English, in your appname.app file, there's a mod specification for when you're starting your applications. If you export in that module a config change, you'll get a notification in your upgrade. And then it marks the release as installed in memory. So it's saying it doesn't actually make it permanent. So it's kind of it allows you to see what's going to happen when you upgrade it without kind of permanently adding a bug that you didn't see in your upgrade. And so I should say, generally speaking, when we install an upgrade, we'll let it sit for anywhere from 10 minutes to a couple hours, depending on what we've upgraded, depending on how. Depending on the size of the upgrade, if you've added, a new application or something, you might want to look at its runtime performance. You want to be able to, is this going to behave on this particular cluster? So that's very useful. And then make permanent is usually pretty quick. It'll update that starter old data, the releases to say that it's permanent. And then one interesting thing I found out the other day is it actually updates the boot and config command line arguments. So that way, if you do an init reboot, it'll actually boot correctly. So some more specifics on net. So my GitHub account, it's very alpha at this point. But my whole entire goal with this, because in my experience, there aren't a lot of people that either use releases, or if they do use releases, they don't use upgrades. And so I'd really like to try and make it easy for people to generate upgrades and test them, because I think they're pretty awesome. And like I say, my goal is to, just typing net should get you most of the way there. If you need to tweak things, then you have to read the readmes and whatnot. But the use of rel tools is interesting, but it's kind of it has a knob for everything under the sun. And most people, I think it leads to a lot of confusion. And I think, if we just had a system where it was just, here's what a release looks like, it would be a lot simpler. I talked about releases, upgrade targets, include duplicate code. If I know I'm going to upgrade from these 3 versions and they all have this version of an app, there shouldn't be any reason to include it. So just for when you're distributing, targets to your infrastructure, that would slim down on network usage. And then another thing, so rebar does not do this. Relx does this. When you create a release, it will install things like a set of bin scripts to actually start your application. And so it does all the shell foo, and it does all of the the correct paths and VM flags to get your things kind of installed. Knit does this. The other thing though is, if I'm focusing on creating upgrades, is tooling to do those release handler function calls from the command line. So that way, if we give software to operators, we don't have to require them to learn rem shell and how to run those those Erlang commands from the shell. So, all right. This next section is basically kind of just a few examples of the way things break during upgrades to try and keep in mind. The first is a fairly obvious dumb thing. But if your process is sitting somewhere stuck in a receive, you'll never be able to get it to the next point where it calls a fully qualified function. So it'll never upgrade. So one of the ways that you can do this is just set a timeout and have it loop through. One of my bigger issues in production environments is sharing records is very bad. Outside of a single module, when you have a cluster running and you have these records in memory somewhere, it's very surprising how long they can live in memory. And so after you've done upgrades and then all of a sudden you start getting bad matches and or bad records exceptions. And so we've gone through a lot of effort trying to remove public record definitions from all of our code. That one is, and it's, yeah, that one. So yeah, anyway, sorry. And we just do that by just making them private to a module and having getter accessor functions to each record. And like I say, it breaks upgrades off enough that I'm trying to make them just private to modules and never have them in an actual header file. I'm going to say messages in the ether. Anytime you're doing RPC type calls, like those messages can live. If you have a slow gen server that has a large mailbox, I've been surprised a number of times on messages reappearing after an upgrade. And the ordering of code loading, like I was talking about with the gen server with the utility module behind it. It's interesting that the way that the relups are defined, the ordering is not defined, but it is deterministic. And so you can run upgrades that work for a while, and then like the 5th upgrade, all of a sudden 2 modules will change, and then you'll realize that you had a dependency there that you didn't know about. And the other big one after modules is anonymous functions are the devil. Anytime you have an anonymous function living past the scope of the function where it was defined is a recipe for disaster. Did I just turn? No. The interesting thing to me is you don't actually have to be executing them. You don't have to be looping through an anonymous function for it to break your upgrade. As I understand it, it's basically just a pointer into a module file, into an actual binary file. So just referencing an anonymous function anywhere in your code, that process is marked as having old code. And that is, I've spent many hours removing references to anonymous functions. The APIs that I generally go for are either just an MFA or a fun, because you can use a fully qualified function there, but then with some state in case you need, rather than, I should be more specific. Usually when I see anonymous functions, they're capturing scope. They're using the closure to kind of, instead of passing the state explicitly. So that's caused a lot of broken upgrades. One of the other big things, supervision tree changes are fairly difficult for upgrades. You have to be very careful and specific on them, and this is one of the things is, your supervisor child specifications come from a function, so there's no static analysis of these are, the children that I used to have and these are children I need to have, and then being able to automatically kill some of the children and load the new ones. So that knit apply is hopefully, will allow us to at least make that a little bit easier. I'd really like to figure out a better way to do this, but I don't see a way through the dynamic specification of the child specs. But luckily in actual use, we don't do it that often. It's just that when it does happen, it's kind of a pain. Another one, the release handler of the process is a registered process. We actually have a bit of code that allows clients to ask, what version of code are you running? I've actually had that screw with releases because it's a heavyweight operation, and so that will run slow and as it's trying to do the upgrade. It's not terrible, it's just, as you're doing an upgrade and you sit there for 5 minutes, you're like, is this running? Or is it, is something in the upgrade stuck? The other one, I don't know how many people do, RPC calls, but this is one of our more heavyweight upgrades. This actually takes about 4. So you'll do an upgrade to add code on all of your nodes. You'll do an upgrade to start calling it. And then you'll do an upgrade to, when you add the code, you add it as a second module, and you basically go back. that is, I'm not entirely certain if there's something in it that we need to kind of do for this, or if that's just kind of a pattern that we need to look at more closely. That's it. Any questions?
Hi. How do you solve the NL problem? Like you said, if you use NL, you load Beam on a lot of nodes. But if you restart them, they will fall back to the old version.
Right.
So
How do you fix that? Well, you use upgrades is the best way. That's one of the things is that I'm focused on when I have free time, is trying to make these much easier to generate and then ship to actual nodes and do that. If you're in a pinch, I just SCP to the entire cluster, and that way when they do it, they'll pick up the version that's on disk. But that's the important part is basically that NL, it just puts it into RAM. It doesn't actually write into disk. But if you do that by hand, then you can do it. So, but yeah, if I had more time, as we all say, I would just dictate that we wouldn't do it in production. If you ever wanted to do that, you would use an upgrade. But it saved our butts a number of times. So.
Thanks.
Hi. Is knit supposed to replace relics and rebar?
Say it again.
Is knit supposed to replace relics and rebar?
Just the two commands, just the generate release, just the generate app-ups.
Okay.
But yeah, no, all of this require, I rely on rebar to compile and everything like that. No. And it's, whether or not I donate this back to rebar and whatnot, or relics or one of them, that's fine. It's just, right now trying to play with these things and get a better idea on how to do this. Because this originally started as an idea to try and write those scripts by hand with, I could never find a syntax. So until I think I have something that I've used for a while, I don't want to burden another project with a PR that might be pointless.
Yeah.
Oh.
Sorry.
What kind of system are you using this for right now? And do you find that it's really actually worth it to you to do these live upgrades rather than actually shutting down nodes and bringing them back up again with a new version? Oh,
so that's a good question. So the system we're using is a distributed version of CouchDB. So it's a distributed database, Dynamo style distribution. The bigger question though is why not do rolling reboots instead of upgrades? The brutally honest answer is that decision was made before I got there. And so they've been doing upgrades for a long time, and it's kind of been to our detriment a little bit because all of the upgrades we do are Erlang upgrades. Our focus on actually booting a node has not been completely there. And so some of our larger clusters, you'll get stampeding herd effects because as that node comes up and all of a sudden it looks like it's available to take RPC requests, you can have a couple hundred nodes, nailing that node. And so it's easier, in a lot of circumstances to not take them down. That said, there are a number of times where upgrades can be very difficult. And, you spend more time thinking about how to write the upgrade rather than the 5-line patch that, you just wrote, and just being able to just do a rolling upgrade would be useful. So I would say that both are useful. And in most of the cases that that we do, upgrades I think are very nice because you're not taking down machines. But it's important that your nodes can come back very quickly, which we're not very good at. So. Oh, speaking of which, one other comment on that. Heart is actually a very good example of, or not Heart, APMD is a good example of a stampeding herd. On that, one of our large clusters, we have so many people, when that node goes down, So obviously, everybody knows when Erlang comes up, it starts EPMD, which is the, is everybody familiar with EPMD? Okay. So when that node goes down, EPMD is still there, and then all the other nodes in the cluster start trying to find that node, and then you basically will exhaust your ports on, I can't remember the port for EPMD off the top of my head, but that's another example of when you don't want a node to go down, is because that's stampeding hurt on EPMD itself.
Yeah, actually on that subject, we have problems where we just cause EPMD to start the Erlang nodes in our startup scripts. So what I was going to ask was, how often using upgrades do you find the sort of time bomb effect where you've made a mistaken upgrade but not realized your upgrade was a mistake? So you end up with a node that works after the upgrade but doesn't boot if you restart it.
I don't think I've ever had that. I don't think I've ever had a node refuse to boot after an upgrade.
So if you patch the supervision tree, for instance, you can have accidentally relied on a new process that requires to be started before another process. And then when you restart the node, of course, the process isn't there, but it was there when you patched it.
I haven't seen anything like that, but yeah. I mean, I could definitely see how you would get in that position, and it's, yeah. I mean, I could see that, but I haven't seen it personally. But yeah, there would be some yelling.
Tough problem. I just saw that in the last slides you presented some kind of rules that an application needs to conform in order that it could be upgraded in life. Is it a good idea to write some kind of post-compiling something, code analysis in traversing the abstract syntax tree in order to emit some warnings that maybe that code won't be upgraded? Is it possible, or
You're saying,
do you think?
Is it possible to warn that something might be hard to upgrade?
Yeah, can be some kind of code analyzer to.
It's hard to say. I mean, you're saying, if I have this right, you're saying, can I, if I make a patch, is there some sort of static analysis that would make it kind of a, maybe? I would say it's not impossible, but it seems like having one of the like the 7 things for performance in Erlang. It's something like, you know, kind of a best practices or an examples of things that are hard would be more productive, because it can be very surprising what things are hard and what things are not. So, yeah, I don't know.
Yeah, at least a good topic to research.
Cool.
Yeah, so thank you very much, and we will have the next presentation 5 minutes later. Okay.